different number systems that we have around. We have decimal, we have binary, we have octo, hexadecimal, and others. However, for today we are going to convert decimal to binary number systems. For decimal, we know that it's in base 10. Decimal, the base is 10. For binary, the base is 2. There are two methods to convert decimal to binary number systems. First one is place value method. The place value method. Next one is long division method. Long division method. Which one do we start with? 1, 2, 3, 4, 5, 6. Chances are saying that I start with the long division method, whereby we'll start with a number like 32, base 10 to binary. And for this one, we have said the song has shown us how to use we are going to use long division method first, but we are going to still use both. But let's start with this one. For the long division method, just divide like you had divided in class 2. Every time binary, we divide by 2, whereby we know that 2 divided by 2, if we divide it using the old school method, we're going to have 1 because of 2. Then we have 1, 12. Then we divide by 6. What am I doing? Yes, by 6, because 6 times 2 is 12, and we have a remainder of 0. So we write 32 divided by 2 is 16, remainder 0. We divide again by 2. Now 16 divided by 2 is 8, because 8 times 2 is 16. So once we subtract, we get a remainder of what? 0. So we write remainder 0. We divide again. 8 divided by 2, 4. Remainder 0. We are now getting the hang of it. 4 divided by 2 is 2. Because even if we write 4, we divide by 2, we know 2 times 2 will give us 4. And even if we subtract, there will be just 0 as a remainder. So it's 2, remainder 0. Still again, we divide. 2 divided by 2 is 1, remainder 0, because we know that even if we write 2, we divide by 2, we'll have 1, remainder what? 0. However, this last one, just have it to the extreme right, and then read the number upwards. So for us to read the number upwards, we'll have 1, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, base 2. And that is the long division method. Next, let's do the same number using place value method. Now for this one, we are going to write powers of 2, and we do that one in a table. So we start from powers of 2 until we go to a number which is greater than or equal to 32. So we start with 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. Okay, let me just go to 2 raised to power 6. We have said a number which is greater than or equal to 32. So let's subdivide our table. I'm just making it easier for us to be able to understand. Now 2 raised to power 2 is what? 2 raised to power 0 is 1. 2 raised to power 1 is 2. 2 raised to power 2, 4. 2 raised to power 3, 8. 2 raised to power 4, 16. 2 raised to power 5, 32. 2 raised to power 6 is 64. Separate it that way. Now from that, our number is what? 32. So we start with this one. We have said a number greater than or equal to the number. Let's just use the greater one because there will be no change, no difference. 32 minus 64. Can we subtract? No, because it will give us a negative. So if we can't subtract, we write 0. Let's move the 32, which cannot be subtracted, to the other number. 32 minus 32. Can we be able to subtract? Yes. If we can be able to subtract, we write 1. So let us now subtract. 32 minus 32 is 0. So we write 0. 0, we subtract the number that we have, 16. Can we be able to subtract? No. We take the number which cannot be subtracted, 0 minus 8. Can we be able to subtract? No. We write 0. We take this 0 again, 0 subtracted by from 4. Can we be able to subtract? No. So we write 0. So we go again to 0. We subtract by 2 from 2. Can we be able to subtract? No. So we write 0. Finally, 0. Can we be able to subtract from 1? No. No. Base. And we get up to that point. So finally, our number is 1 0 0 0 0 base 2. Let's check whether it's the same as the one that we had found above. How many zeros are here? 2, 3, 4, 5. How many zeros in this case? 1, 2, 3, 4, 5. So which one is easier? Even if we wrote 0 here, will it be significant? No. So those are the easy methods to convert numbers to binary number system.